There we go. Bless you. It's a great way to start a recording with a sneeze. All right, so today, I want to make sure everyone has the Fluid Grid project files up. You should have an HTML, a PNG file, and that CSS document that we had created. The goal of this particular series of lectures was to recreate this particular layout using a Fluid Grid. And as I mentioned on Monday, the Fluid Grid is kind of the first step towards understanding responsive design. We got close. We were able to do some of the various text and font styles. And if we come back over here and we take a look at our CSS, or excuse me, not the CSS, let's go look at what we actually finished. This is the HTML document that we completed at the end of Monday. So once again, the layout itself is not complete, but as far as font sizes go and all the different typesetting, colors, all of that is taken care of. Anybody have any questions over any of the typesetting CSS that we went over on Monday? And now one of the biggest changes we made, go back to Adobe Code here, and let me just come on down here, is the use of M's. So if you remember, back on Monday, we converted pixel-based static values to M's. Now, 1 M equals what? Is that always true, though?
No.
No, 1 M does not always equal 16 pixels. Why not?
Because you can define it with font size.
Can you be a bit more specific? What does an M get its value from?
The font size itself.
The font size itself. So remember, that's a holdover from the print world. This is not something that's specific just to web. So in the print world, if you were typesetting text and it was, say, 24 points, 1 M would equal 24 points. If you were typesetting something at 10 points, 1 M would equal 10 points. Okay? So when we are using M's in our CSS, yes, by default, an M equals 16 pixels because 16 pixels is what? The default, the default font size. Okay, all browsers default to 16 pixels as their font size. Now, we began by targeting the body, and we set, using the font shorthand, we actually set the font size to 100%. Everybody remember that? What was the reason why we chose 100% instead of just saying 16 pixels?
Because browsers like to, they don't like to go above the set pixel size. I mean, font size.
I know where you're going. It's close.
If you've stated that it's pixels and you want to change it, I said no, you said pixels. You said 16 pixels.
If who wants to change the font size?
The user.
Internet Explorer.
Yeah, okay, so to be more specific, so between these three answers, I think we've got one. Okay, so yes, here's the thing. If you set your font size in pixels, there are browsers that will not allow the user to actually change the font size. And I said one of the ones that were more egregious in this particular behavior was Internet Explorer. Okay, so the older versions of Internet Explorer, not necessarily the latest ones, because the latest ones use page zooming and instead of actually changing the font size. But it is best to go ahead and do this. Now, there was a second reason why we set it to 100% instead of using something like, say, 1 M or 16 pixels. What was the reason for using percentages specifically?
Ease of adjusting your overall layout.
Well, that's one. That's certainly a byproduct, is the ease of adjusting it, because you can, if you want to make everything bigger, you just change it to, like, say, 110%, or if you want to make it smaller, make it 90%. That's certainly one way of doing it. But there was another reason as to why we use percentage.
Because if you want to increase the general size of the whole font, you don't have to go individually to change the size.
Right. Yeah, we're coming at it from different angles here. We've got it surrounded. What is the reason? Remember, I said it was very specific. It had to deal with browsers. and how browsers rendered text. Remember this? Apparently I didn't emphasize this enough on Monday. We use percentages because certain browsers will render non-static value fonts differently. So in other words, if I am specifying something at 16 pixels, all browsers know how to render 16 pixels. So across the board, 16 pixels is 16 pixels is 16 pixels. They all look the same, meaning height, width, everything looks the same. So if I'm looking at Times rendered at 16 pixels on an Internet Explorer or Opera or Firefox or Safari, it looks the same. However, the minute you start using dynamic values, EMS for instance, what you end up seeing is slight variations in how each browser actually renders that text. Remember this now? I guess not. Okay, some people are just like looking at me like, yeah, I remember it. And you have this face like, I have no idea what you're talking about.
Because if you're changing the size of the window, then the browser says, it starts freaking out.
Well, it's not really going to deal with device width or anything like that. It has nothing to do with the actual browser dimensions. It just has to deal with how the text is actually just going to be rendered by the browser. So when you're using static values, all the browsers get it. When you start using dynamic values, unfortunately, what a lot of tests actually show is that browsers have their own kind of opinion on what these dynamic values actually mean. So the odd thing is that the same tests found that if you use 100% on your body tag and you set all of the font to 100%, which of course is the same thing as saying the default. Agreed? 100% of whatever you had originally is the default. But if you set it to 100%, not only are you allowing yourself to use a dynamic value, which is, as you guys were saying before, easily change. You can make things bigger or smaller just by changing that default value up or down without having to go through each individual selector. But at the same time, what we found out is that, yes, it is a dynamic value, but it's like the holy grail of dynamic values. It allows us, if we set it to 100%, it allows each browser to render the font precisely across the board. So instead of having these odd variations, if we said the font size needs to be 1M, which is the same thing as saying 16 pixels as well, but if we say 1M, the browsers across the board are going to render the fonts a little bit differently. If we say 100%, suddenly all the browsers seem to go, oh, sure, yeah, not a problem. And all the text is rendered properly, just as if you were to say 16 pixels. So this is what you need to make sure you're doing in your CSS. Whenever you're setting the font size on your body, you want to make sure you always set it to 100%. Any questions about that before we go on?
So I know you said it helps the browsers be standardized with each other in a word, right? But is it also because do the browsers not like the mixing of pixels and M's?
It's not necessarily that they don't like they don't like to have to render or play with pixels and M's at the same time. It just has to deal with how those browsers interpret those particular values.
Okay.
All browsers interpret pixels the same way. Well, almost. We'll talk about subpixel rendering here shortly. But for the most part, if you're using a whole value pixel, every single browser pretty much behaves exactly the way you expect it to behave. When you start using dynamic values, there's some slight variations on a theme, essentially. And it's almost like if you think of music, it's like some browsers hit the tone exactly right, or on key, and some browsers are a little flat, some browsers are a little sharp. It's like, you're not quite hitting that note. It's the same idea here. It's like you can render that text, and it's like you're not quite making it big enough as opposed to, say, the other browsers. Or it's a little bit too small. It needs, or it's too large, maybe the opposite. So setting it to 100% will make sure that all browsers play fairly. So that's the reason why I want to do that. Now, in order for us to actually convert values to M's, what we needed to do was we needed to actually learn a new mathematical equation, to which everybody in the class was excited to find out on Monday, because you guys just love math. So what we learned was, how do you take whatever it is that you want to actually adjust? So let's say we want to adjust a font size. If we want to make it bigger, so in the case of our first level heading, if we wanted it to be 48 pixels, how do we convert that 48 pixels to M's? a dynamic value. And what we talked about was to go in here and say, okay, well, we need to learn this equation. And the equation is the target value, so we want it to be 48 pixels, is divided by the context. In this case, what font size the element is currently set to. So it could be a font size that you had set explicitly, or it could be a font size that you had allowed this element to inherit. Now, by default, every single element inherits the same font size, which is what? 16 pixels, because that's a default font size. So every single element, even the ones that the browser likes to play around with and add its own user agent styles, every single element inherits 16 pixels as its font size. And if we set it to 100% in the body, it's still 16 pixels. Okay, so that's the context that we're working with. In the case of our first level heading here, we wanted to change it to 48 pixels. That's the target. So the idea here is that we want to divide 48 pixels by 16. So 48 is the target, divided by 16, which is the context. And that gets us a value of 3. Okay, so 48 divided by 16 is 3, which means that the value is 3 ems. And I also mentioned, we take a look up here, you want to make sure you show your work. Okay, like an evil math professor, I'm forcing you to show your work. You have to comment it out and put it over here on the right-hand side. Now that does two things. One, it shows me you know what you're doing, but two, it shows you know what you're doing. Because if you ever have to revisit this particular design 6 months down the road or a year down the road, you don't want to have to try to figure out what those ems actually mean in pixels. Just like it's been 2 days since we looked at this, and because we've actually commented this out, the minute you open it up, you knew exactly how many pixels that 3M was actually equivalent to, right? Because we commented it. That was nice. Yes, it's a little bit extra work, but that's what it is. Now, after we had set the font size to that specific element, we had a shift in the context. No longer was that element using 16 pixels for its context. So any other value that we were setting to ems, line height, margin, we had to shift its context as well. So that's why if we want the line height to be 55 pixels, the context was now 48 pixels because that is the equivalent font size. Because once again, the element, if you are explicitly setting its font size, that will be done first by the browser. Then the rest of the values will be calculated based on that font size. Does that make sense? If you don't set the font size, then it'll just use whatever it has inherited. So whatever its parent element is currently set to, or its grandparent element, or so on and so forth. Any questions about converting to ems before we finish this out today? Yes, sir.
Still not getting it. I get
Still not getting the ems?
I get the first part, but the second part about
Why the context changed?
yeah. Like,
Because we've changed the font size for the element.
so for after the 55 pixel line, what is 1 M now?
Right here, the margin bottom. So the bottom margin is set to 1M because we wanted the bottom margin to be equivalent to 48 pixels. That's the target. Okay, so in other words, we were saying we wanted the bottom margin to be the equivalent of our font size, which is also 48 pixels. However, because we explicitly changed the font size for this first level heading, it's not 48 divided by 16, it's 48 divided by 48, because the font size of this element is now 48 pixels. Whenever you are converting, here's a better way of thinking about it. Just think about this rule. Whenever you are converting a value to ems, okay, as long as the property is not the font size property, okay, if you're not actually doing this, it could be anything. It could be padding, it could be borders, it could be margins, okay. Any value you convert to ems, ask yourself this question. Have I also changed the font size of this element? And if the answer is yes, then you need to use the equivalent font size that you've changed as your context. If the answer is no, then you just need to use whatever font size that element is already inherited. If that happens to be the default, it happens to be the default. Okay? Are you sure? I want to make sure everyone at least... Okay, all right. Well, let's move on. Any other questions before we continue? All right, so our CSS, for the most part, is pretty straightforward. Everything that we did, we had converted to M's. So then the next thing we've got to do, and let's go ahead and bring up our HTML, and I will go ahead and bring up our image now. This is the layout that we want to go for. Now, if you'll notice, it is a kind of a pseudo 3-column layout. This is the next step. Now, I will tell you this. This particular layout is based on a grid. In other words, if you were to lay columns over this particular layout, what you'll find is that this particular layout is based on a 124 pixel wide column with 20 pixel gutters. So for instance, if I lay a 124 pixel column over this first, on this left side, this left column right here, you'll notice that this left column is exactly 124 pixels wide. So is the one on the right hand side. The gutter between them is exactly 20 pixels. If you were to continue laying over 124 pixel columns with 20 pixel gutters, you'll find that the inside content lines up perfectly. So everything is based on a column layout. Now later on in this class, I'll introduce you to a couple of different grid-based structures like the 960 grid and the Twitter Bootstrap structure, which is all based on columns. The idea is, just like anything else, when we're doing print design, for instance, if you break up the design into a grid or a column structure, it gives your design a bit more organization. So the same thing happens here. The overall design in this particular case is 988 pixels. 988 pixels. Everyone with me so far? Yes, no, maybe. Yeah. Okay. All right. Good. Good. Just making sure I'm not getting any feedback. I'm getting people looking at me like I have no idea what you're talking about. All right. So knowing that it's 988 pixels wide, we could, of course, if this was a static layout, we could set things up. We can go ahead and find the container for our entire design and set it to, say, 988 pixels wide, right? Use the margin technique to center it. Agreed? And then we can apply things like floats to be able to make our columns actually work the way that they need to work. Everyone see that? Okay, so here's what we're going to do. We're going to approach this right now like what we did with the fonts. We're going to approach this as though we are creating a static-based layout. Now what we're going to do, though, is I'm going to introduce a couple of properties we haven't talked about that will go into this whole fluid grid. But at the same time, while we are adding these static values, we will convert them into M's, or percentages. Everyone with me? Okay, so let's get started. Let's go ahead and open up our HTML document, please. All right, first off, someone find me the container for the entire design. Does it have an ID or a class, and if so, what is it?
Page.
What is the element itself? What type of element is it?
Division.
Yeah, it's a division tag. What's the ID again?
Page.
Page. And what line do you have it on? I think mine is 9. Everyone see that? Okay. All right, so jump back into your CSS. And let's, we'll go ahead and do this after all of our type styles. Let's go ahead and target that specific element using an ID selector. And let's set its width. 988 pixels. Everyone with me? Okay. Next, let's go ahead and set its margin. Now, how do we center using the margin property?
Set the left and right margins to auto.
Yeah, we can set the top and the bottom margin to whatever we want. For right now, let's just go ahead and set those to 0. But the left and right margins have to be set to auto. So after we've done this one change in our CSS, let's go ahead and save it, refresh the browser, and let's see what it looks like. And now we've got the makings of a static layout. Width is 988. Margin is 0 auto. Okay? Now, next thing we're going to do, bless you, let's convert this, the width, to ems. So, we're going to show our work. So let's create some comments here. If we're going to convert this particular element to ems, what is the target?
16.
No, the target.
988.
Yeah, 988 pixels. What is the context?
16.
Why is it 16?
Because that's the standard.
That's what the body's set to.
Not only that, that is what this element has inherited as its font size. Agree? Okay, so this division tag is actually the immediate child of the body element. Okay, so it also has a default font size of 16 pixels. All ems are derived from the font size. So because that's the case, 988 pixels is our target. 16 pixels is our context. Anyone want to actually do the math on that and find out exactly what that is?
61.75.
Oh, there we go. You guys kind of jumped right in there. You didn't even give me a chance to take my shoes off and use my toes. 61.75. 61.75 ems. So let's replace the width with 61.75 ems. Now, if you did this right, you save it, you refresh the browser, nothing should change. In fact, it's not even really fluid if we think about it. If we look at it, it's like, okay, I get my horizontal scroll bars. This is not really exciting. I thought we were going to make something fluid. We are going to make something fluid. There's going to be one small change we need to make here, and suddenly you'll start to see the genius of this plan. And that is, we're not going to actually use width. We're going to use a different property altogether. The idea behind this particular technique is that what we want to do is we want to tell the browser that when the browser window reaches a certain width, from that point on, as it continues to expand, when it reaches that limit, at that point, the design will stop expanding with the browser window and suddenly become a static design. Does that make sense? Now, the opposite is not true. As the browser window contracts or gets smaller inside of that limit that we set, then the design is allowed essentially to also collapse with the browser window, essentially removing the need for a horizontal scroll bar. Is everybody with me? So here's the nice thing. Instead of setting width as the property, what we really want to do is that we want to set 61.75 ems as this element's maximum width. It could be smaller than this, but the element itself cannot grow past 61.75 ems, or the equivalent of 988 pixels. So add the word max and a dash to the width property. So now it should say max width 61.75 ems. Now, refresh the browser. As you expand the browser, it should remain static. But the minute you start collapsing it inside, all of a sudden now everything wraps. Do you see that? Now, in this particular case, if for those of you who've had me in my digital publishing class, I always harp on things like measure length, especially when we're talking about readability issues in your work, and you want to make sure you try to attain a ideal measure length. And if you've had me in digital publishing, I also hand out that ridiculous looking typesetting grid. You guys remember that? For those of you who've had me before, okay, and we are trying to find a specific ideal measure length based on 66 characters, which is considered ideal, and then there's a range of characters that go inside and outside of that. The nice thing about these kind of fluid grid designs, and later on when we talk about responsive design, is you can apply the same technique and the same theory to your web design now. Using max width, you now have a way to be able to essentially tell the browser, okay, when you get to this specific point, when the measure length is going to grow past this specific point, stop allowing it to expand. That's the maximum. That's it. Now, there is an opposite as well. There is also a minimum width that you can set if you want to go the opposite end of the spectrum. But setting the maximum width will ensure that if somebody ends up having a 4K 40-inch monitor and they like using, like browsing the internet at full screen, that will ensure that your design will at least kind of stay within a certain limit and will not become grotesquely out of shape, so to speak. Okay, so do you start to see the fluidity now that we're adding to this particular design? Okay, all right, now, with that being done, one other thing we need to talk about with this particular container is if we go back to the image, you'll notice there's some extra space at the top and at the bottom of our particular design. Now, in this case, the designer actually added margin to the top and the bottom of the container. So if we go back to our CSS, we just want to adjust the margin and replace that 0 value for the top and the bottom to just 40 pixels. Now, 40 pixels, we can of course convert that if we want to ems, right? But for right now, because we're running out of time and the Snowpocalypse Part 2 is upon us, we'll go ahead and move on. All right? Any questions so far? How are we feeling about this? Good? All right. So go ahead and save that. Let's refresh. Just make sure the 40 pixels are looking good. There we go. It's looking a lot better than we did before. Now, the next thing is we need to take care of these columns. So if you'll notice, we have these two specific columns right here. And we've got our first level heading. We've got our second level heading. The blog entry is actually a third level heading, if I'm not mistaken. We got a bunch of paragraphs, and at the very bottom of our paragraphs is actually this division that is set up using the class name meta. So if we take a look at the actual structure, inside of the page we have our first level heading. Then there's another container called, or we give it the class name of entry. There's our second level header. There's our third level heading, and that is actually in the design the left column. Then we have another container called content, which is split up between the main container and the meta container. And the meta container in this case is actually the right column. Everyone with me so far? All right, so if we were to go back and take a look at the final design, this section right here, the main body of our content and the right column, or the meta, those are two separate sections within a single container. So what I am currently highlighting right now is the single container. It's made up of this content and then the meta. Everybody with me? Okay? In fact, I can probably define it a little bit more because the second level heading is not part of the container. So technically, it's just these two elements. The paragraphs in the center and the meta on the right. So in order for us to actually create this specific design, this visual design, what we're going to do is that we're going to employ floats. We're going to float the meta to the right of the main content. Okay, so those two things are going to be floated. So in this case, those two columns are going to be created exactly like we're used to creating columns, multiple columns from Web 1. We're going to float them. Now take a look up over here. We have third level heading and a second level heading. Everyone see that? In our HTML, we have the second level heading and we have the third level heading. Could we not do the same thing with those two elements? Could we not also float those? Sure we could. As far as the space to the left of the first level heading, well, that can just easily be added by applying a margin. Furthermore, notice the word will and not do not appear over here. Do you see how it's wrapped? What's happening here is the first level heading is given the same width as the text below it. The margin, though, on the right side is actually adjusted. That's what makes that first level heading scoot over. So as we're going through this, when you are creating a specific layout, sometimes it helps to kind of break things down visually in that regard, so it can help you a little bit as far as understanding how the structure needs to be done, how you need to group elements together, and how those elements are going to relate to each other in the actual layout in regard to things like floats or positioning or margins. So let's go ahead and start with the topmost element, and in this case it's going to be our first level heading. So let's go back into our HTML, and is there a class name or an ID that allows us to actually target the first level heading? Yeah, there's no class name or ID on it though, right? So the only way we can actually target our first level heading is by using a type selector. So go back in your CSS, and yes, I know we have another one up here, and that's fine, but let's just keep all our layout in the same place. So let's go ahead and create another type selector just for our H1. If I was doing this for real, I'd probably add all these properties up with the same selector on top, but for right now, let's go ahead and leave it as is. All right, first thing we're going to do. If you remember, I told you that this particular design, whoops, come back right here. This particular design is made up of 124 pixel wide columns with 20 pixel wide gutters. So if you know that this left column is 124 pixels wide, and then it also has a 20 pixel gutter, what is the total width of that space, or more specifically, what is the total width of our left margin for the first level heading? 144. That's right. Anybody have a question on how we calculated 144?
What were the numbers again?
If the left column is 124 pixels wide with a 20 pixel gutter, what is the amount of space for the left margin?
For some reason I heard it 120.
Oh yeah, no, not 120. 124 plus 20 equals, I don't have that many fingers or toes, 144. Okay? So, in our CSS, the first thing we're going to say is margin left, 144 pixels. All right, next thing we're going to do. We're going to convert when we're doing our layout, we're going to convert any of our horizontal values. Instead of using M's, what we're going to do is we're going to use percentages. So now here's something new. Another wrench to kind of throw into our understanding of these various fluid or fluid grid designs, excuse me. We're going to convert these to percentages. Now, I will tell you this. The equation we're going to use to create percentages is exactly the same as M's. However, the context. When you are converting something to M's, M's are always going to be derived from the font size. Right? When you are converting something to percentages, percentages are not derived by the font size. So the context in this particular case is going to be based on the parent element. Let me give you an example. The left margin, or in this case the overall design, the left margin, we want it to be 144 pixels. If we were to convert this to a percentage, so just bear with me. Let's say that's 144 pixels, okay? We want that to be 144 pixels. If we're converting it to a percentage, it needs to be a percentage of what total value? 988 pixels. We are telling the design that we want the left margin of the first level heading to be a percentage of our overall design. Does that make sense? So in this regard, instead of dividing 144 by 16, which is an M, and we're not doing that, what we really want to say is that we want to divide 144 by 988, which is the overall width of our design. Or in this case, the maximum width of our design. So if we come back in here, once again, show your work. What is going on with my spaces? There we go. So we want to say the target is 144 pixels. We're going to divide it by 988 pixels, which is actually the context. And let me get my calculator out because I know I'm not even that good. Someone correct me if I'm wrong, but I get something like 0.14575. Does that sound about right? All right, so this equals 0.14575. Now, that is a decimal. How do we express that as a percentage? Remember? Yeah, okay, yeah. We can move the decimal place to the right twice, right? Or you could just multiply it by 100. Okay? Potato, potato. Guess it just depends on who your math teacher was in grade school. All right, so in this case, what is the actual percentage?
14.5%.
Yeah, 14.575%. Now, here's the thing with percentages in CSS. I know we were talking about floating point precision and how many decimal places you could possibly want to add for things like it. Okay, I mentioned words like floating point precision, and some of you guys look at me crazy. When I'm talking about how many decimal points you want to actually add to things like M's, I was saying, try to be as accurate as possible. Same thing can really go for percentages. However, when we're dealing with percentages, one of the things we'll talk about here shortly is how browsers actually render partial pixels, which can be a bit of an issue. But for right now, let's be as accurate as possible. Let's go ahead and say that this needs to be not 14%, but 14.575%. So 14.575. Make sure you use the percent sign. Make sure there is no space between the value and the percent sign. When you have that done, save it and refresh the browser. First thing you should see is that the first level heading will now shift over as we now have 14.575% margin on the left side. Furthermore, if we begin to collapse the browser, you'll notice that the margin will also begin to slowly collapse as the browser window gets smaller, because that 14.57%, that value changes as the overall design becomes smaller and smaller and smaller and smaller. So in this particular case, if we're using percentages, it allows us, as the browser window collapses or expands, or more specifically, as the design itself contracts or expands, those percentages are going to be resized. All those values are going to be resized proportionally. Does that make sense? So, in other words, 14% will always be 14%. The whole value may change, but 14% will always be 14%. Any questions about that? Now the next thing, now that we've got that nifty little space set up, the next thing is to figure out what the overall width here needs to actually be for our first level heading. Now I'll tell you, based on this particular design, the overall width of that center column is actually 700 pixels. So after we have set our margin left to 14.575%, let's go ahead and set a width, and let's just set it statically right now to 700 pixels. Set your browser window wide enough so that the max width is hit and you now have a static layout. Refresh the browser and you should be able to see it be exactly 700 pixels. Okay? Now, what this constitutes is 700 pixels is the equivalent of 5 124 pixel columns and 4 20 pixel gutters in between. So if you visualize that, if you think about it, that means that this has, a 124 pixel gutter, 124 pixel column, 20 pixel gutter, another 124 pixel, another gutter, another 124 pixel, and a gutter, another 124 pixel, and a gutter, and another 124 pixel. Everyone got that? Now how you can figure that out is 124 times 5 is 620. That leaves 80 pixels left for the gutters. There's going to be 4 gutters in between, 20 pixels each. Now I wish I had an overlay to actually show you how that looked, but that is the beauty of course, laying things out on a grid. Everything is organized very efficiently. So the center is set up to be 700 pixels wide. Let's go ahead and convert that, though, to a percentage. The target is 700 pixels. What is the context? Once again, 988 pixels. So 700 pixels divided by 988 pixels equals, anybody have a calculator? 0.7085. Can anybody confirm that? Only one person in the class got a calculator out and actually did the work. I'll confirm it. It's correct. 0.7085. Written as a percentage, that's how much?
70.85%.
Yeah, 70.85%. Now if you save it and refresh the browser, there we go. Now, here's the thing. If you notice, we didn't set a right margin. They didn't set a right padding. So as this begins to collapse, you'll see the percentage works really well. And the right side doesn't really encroach on the text. Yes?
Why is it that way?
Did you put a space between the percent and the number?
Yeah, no.
Yes or no?
No.
Okay. Stay with me. Okay. Next thing we want to do. If we take a look at our HTML, we've got this division tag with a class name of entry. Now what that includes, if we go back to our image, that includes all of this. Everything. Second level heading, third level heading, our actual paragraphs, our main content, and then the meta itself. Okay? Now, one of the things about floats is that you should always do what? What's the little technique I always taught you in Web 1? After you float something, you should always do what?
Clear it.
Yeah, you should always try to actually clear it. Now, there are a lot of issues when you're trying to clear floats. Sometimes you can't properly clear them. An interesting thing about floats and clearing floats. You can actually, elements that are floated can be cleared if their parent element is also floated. Does that make sense? So the first thing we want to do is we want to target this particular container that contains all of these columns, because these columns, some things are going to be floated left, some things are going to be floated right. We're going to have a ton of floats in here. Agreed? Okay, so one of the techniques that we'll actually do is we'll target this particular entry and we'll actually float it as well. And just to make sure we don't have any hinky things going on, we're going to set its width to be 100%. So it's going to be 100% of the design, but it's also going to be floated. That way, the elements inside of it will automatically clear for us. Yes?
That's what I was wanting to ask you. The statement you say that elements can be cleared if parent element is
floated. Yeah, the elements inside of it will be cleared essentially if the element is floated itself. So here's what we're going to do. We're going to go in here in our CSS, and after our first level heading, let's create a class name for entry, which is the class name for our division tag. Go ahead and set its float to left and give it a width of 100%. And here comes the rain.
Is that what it is?
That is what that is. Right on time. They said 7 o'clock, excuse me, it would be 80% chance of rain. Freezing rain, sleet, snow, ice. Snowpocalypse Part 2 is here. The sequel. Which is better than Sharknado 2. Neither have I, but I heard they're making a third one.
It's a hit though.
I guess.
Enough people like it, or at least seen it to warrant making a third one.
Alright, so we'll save this, refresh the browser. Nothing should change. If you did everything right, nothing changed. This is just a consideration for the fact that we're going to have some crazy floats going on with all the elements inside of this particular container. So with that being said, the next thing that we actually want to do is we want to take care of our second level heading and our third level heading. So if we take a look at this, the next elements that we're going to deal with are these right here. Our second level heading and our third level heading. Okay? Now, in the case of our second level heading needs to take up the space that we see here. Okay? Now, you could have, if you wanted to, give it a width or set its right margin like we did with the first level heading, right, to create that space over here on the left-hand side. But if you notice, we have content over here on the left-hand side. It's not just going to all be margin. We have this third level heading. So essentially what we're going to do here is we're going to tell the browser that we want the third level heading to float to the right, and we want the second level heading to float to the left. We're going to float them away from each other, so to speak. So what we'll essentially end up doing is that we'll say, okay, we want the width of our third level heading to be equal to whatever that is in pixels. And we want the second level heading to be whatever this is in pixels. And then we'll just set the float to make sure that they're floated against each other or away from each other. Any questions? Yes?
Oh, when we set that margin at the top for that third column over there, it's not
This?
gonna be, that's not big enough. That's just, it was like 5.5 pixels, right? It's tiny. Okay, never mind.
Itty bitty.
Yeah, it's
Very small. All right, so let's get started. Let's begin with our second level heading. Now, our second level heading, if we take a look at it, there's no ID or class name specifically for the second level heading. However, we can use a descendant selector because there may be other second level headings in this document later on down the line. So let's create a descendant selector by using the class name entry and then target the second level heading inside of that. So once again, in our CSS, we'll say entry space second level heading. Yes, sir.
When do you use the comma?
The comma?
Yeah.
Remember, the comma in CSS selectors essentially means and.
And you can't use that if the H2 was separate from the entry. It wasn't in the same container.
If the H2 is separate from the...
The class entry.
Oh, what we're saying is target the second level heading inside of the element with the class name entry.
And comma does what?
Comma means target the class name entry and also target the second level heading. So if we used a comma here, whatever width we apply will also be applied to the entry division tag. We don't want that. We just want it to target just that second level heading. So the first thing we want to do is we want to float this. So let's float this to the right. And now we need to figure out what the width needs to be. So let's go ahead and set the width property, but we need to calculate it. We need to figure it out. So let's take a look. The overall design is how many pixels wide? 988. We know this left column, or this pseudo left column, is 124 pixels with a 20 pixel gutter. So if we know that, and we know the overall design is 988.
844.
How did you get 844? Which is correct, by the way.
988 minus whatever you just said. 144.
Okay, so if you take the left column is 124 pixels and the gutter, which is 20 pixels, you add that together, you get 144. Agreed? Okay. If you know the overall design is 988, if you subtract 144 from 988, you get 844. Does everyone agree with our math? Anyone want to challenge it? No. All right. So let's come back in here and let's set this to 844 pixels. Save it. Refresh the browser. Second level heading should be exactly underneath the left side of the first level heading. If it's not, You may want to check your left margin for your first level heading. You may have written it down wrong. Any questions so far?
Mine doesn't quite look like that. I've got a bigger space in between block and one.
Your widths are wrong. Let's see. Not max width, just width. There you go. Okay. Next, let's take care of our third level heading. And when we're done with that, we'll come back and we'll convert these to percentages. Yes? Yours is also wonky. Okay, let's take a look. Oh, it's just not paying attention. Just a space you make that. There we go. Anybody else? I'm on a roll. Yeah.
No, or
That was a lovely laugh. That was beautiful.
I thought I'd be your friend. But I'm a friend.
So rude.
Yeah, right.
Yeah, well, we'll take a look at it when we're finished. Something's a little bit off in the calculations. Okay, let's get back on this. Let's go ahead and let's create the styles that we need in order to target, or select or to target, our third level heading. So our third level heading actually, thankfully, in this particular HTML, actually has a class name. And the class name for this one is info. So all we really need to do is actually just target that specific class name, which is nice. So we'll come back here into our CSS. And let's create a class for info. Which direction is this one going to float? Left. There we go. And what is the width for this? Wrong.
124.
124. Why 124 and not 144? Because we need to keep the gutter. We need to maintain the gutter. Because what happens if it's not just a blog entry? What if it's a blog entry and additional text? We don't want our content essentially to touch. So by keeping that 20 pixel gutter in our calculations, everything will be fine. So the width in this case needs to be 124 pixels, not 144. Any questions as to why that is, again? Are we okay with it? All right, now let's go back and let's convert these two values to percentages. So let's start with our second level heading. The target is 844 pixels divided by what is the context?
988.
988. Equals
0.85425.
0.8425. There we go. Expressed as a percentage?
85.43.
No, we want to be precise. 85.425%. Any questions on how we got that as far as a percentage? Do the same thing with our class name info. target is 124 pixels divided by 988 pixels. I will get my calculator out this time. Equals to, I get 12.550607. That's a mouthful. Now notice, the two percentages, the two widths, do not total 100%, do they? I mean, they don't. The percentage that's left out essentially becomes our gutter. Any questions about this? So remember in Web 1, I said there are several different ways to create gutters when you float. You could set things up using margins, which is never an elegant solution given the fact that certain versions of Internet Explorer actually double count the margin when you float an element. Or you can float things away from each other and just make sure that the width of both columns removes the gutter. So in our case, if we have 988 pixel wide design and one column is 124, the other column should be 844 because that leaves exactly 20 pixels in between. Right? Questions? Okay. So, let's save this, refresh the browser. Things are looking pretty good. Now in our case, I've got that nice little I sitting right between our third level heading and our second level heading. That's because, once again, because these two things are floated away from each other, the negative space in between, which is essentially our gutter, also becomes the only space that the text below it can wrap into. And because there's only enough for 20 pixels of space, and our first particular letter happens to be an I, it fits nicely in that 20 pixel gutter space. Everybody see that? Mm-hmm. So this is just a byproduct of the natural text wrap that is applied to any sort of text element when you use a float. We'll get rid of that in just a second. Okay, next thing. If we actually take a look at how a blog entry is aligned with the second level heading, take a look at this. Do you see how the text is actually aligned with the text over here? Come over here and take a look at our image. Are they the same? What's wrong? Yeah, in the design that we're doing right now, a blog entry is actually pretty high up. Okay? Everything is basically aligned. If you think about it, it's almost aligned on the cap height for the second level heading. In the design that we want, it's actually closer to the baseline. Do you see that? Now the reason why that is happens to be with the fact that the baseline for our third level heading has shifted because the font size itself is smaller. So that's why it looks like it's actually increased its height. So if you look right here, that's why it looks like a blog entry is actually higher up in the actual design. It just happens to be because of the actual font size. So one way to counteract this is actually applying a margin to the top of our third level heading to push that down again. Is everybody with me? Okay, so in our particular case, what we can do is we can take a look at the two fonts that we've got. Okay, so let's start off. The second level heading, it has an equivalent font size of what? Let's use pixels for this example. So go back to your CSS, take a look at the math that you were supposed to have written out. The second level heading, 24 pixels. So how do we find that? Remember, we did this back on Monday, so it's a little bit further on up. 20. I know. We're bouncing all over the place today. 24 pixels was the equivalent of our second level heading. Now, what about our third level heading? What's the font size? 11 pixels. Everybody see that? So, if you know the equivalent font size, unfortunately, it doesn't exactly tell you how much space there is between the two baselines. It doesn't really tell you how much is actually shifted between the two baselines. The equivalent shift between a 24 pixel font and an 11 pixel font, if you really just do a simple subtraction, it's about 13 pixels between the two. Agreed? 11 minus 20, or 24 minus 11 equals 13, right? Okay, now remember though, font size is not a measurement of baseline. Font size is a measurement of the ascender to the descender. So it's not just enough to go, hey, let's put 11 pixels at the top of this particular font and everything will be fine. It doesn't quite work that way. The equivalent for these two particular fonts is actually a little bit less than that. It's anywhere between 8 to 9 pixels to shift the baseline down. So what we need to do is come on down here where we have our info class name for our third level heading, and let's add a margin to the top of about 8 pixels. Now for right now, before we actually start shifting things to M's for this particular measurement, let's just play with pixels and see if we can get it about right. So change it to 8, refresh the browser, see if that gets it close enough. If not, change it to 9 and see if that's any better. So you tell me which is better, 8 or 9. Here's 8. Here's 9. It's a pixel of difference between the two. You want to try 10? Go for 10. Yeah, don't try 600. All right, what do we think? Do we like 8 or do we like 9? Let's make a decision because the snow is upon us.
9.
It's 8.
I'll go for 9.
It's
I like 10.
You like 10? There's always one in every group. You like 10? Let's see what 10 looks like. You know what? I'm gonna agree with Angel. Let's go with 10. Makes the math easier as well, shall we? All right, let's make it 10 pixels, shall we? Let's go back over here. And now what we want to do is we want to convert this to M's. Percentages are great for horizontal values. Widths, for instance, left and right margins, left and right paddings. For vertical values, on the other hand, you generally want to use M's. So in our case, we want to use M's. Now, the target in this case is going to be 10 pixels. The context, though, because we're converting it to M's, needs to be based on the font size. That needs to be derived from the font size. So, what is the context for this particular element? In other words, what is the font size of this element? It's 11 pixels. Because we set that back on Monday. So we want to do 10 pixels divided by 11 pixels, and that gets us a total of, my calculator out here.
It's repeating 0.90.
Yeah, it's 0.909090 and on. So let's just say it is 0.90 M's. Save it, refresh, should look pretty good. What do we think? Good, bad, indifferent? All right, getting closer? All right, last two things we need to fix, and then we're done. And there was much rejoicing. So what we got to do now is we now need to set up, oops, excuse me, we don't want the second level heading in this. Our content our main information and our meta. Okay, now, as I said before, the main paragraphs and the meta are contained in their own containing element. So we go back here to the HTML, you'll notice that the meta and the main are contained within a division with a class name of content. So everybody see that? Yeah, they have their own little container. Now this is important because what we want to do is we want to target this particular container. And we actually want it because, once again, the children inside of it are going to be floated. We want to target this container and float that as well. That way we know that its children will be cleared. We don't have to create any clearing elements or anything crazy like that. So the first thing that we want to do is we want to target this content container. We want to set its width and we want to float it. So knowing that, if we take a look at the design, first off, which direction are we going to be floating this container? To the right or the left?
To the right.
To the right. Is the width going to be 100%? No. The width is going to be equal to what other element? What other element did we set this width to? Not the first level heading. The second level heading. Remember, the second level heading actually starts right there on the left-hand side. It goes all the way across the page. Where it's like 80-something% in width. Whereas that was, what, 844 pixels? Right? Now, we already have the math for that, don't we? Yeah, so I don't know about you guys, but I kind of like copy-paste for this. So first off, let's go ahead and create a class selector for content. So I'm going to create a class selector for content.
Could you also combine the entry?
Yes, you could. You could actually combine the two here as well.
Do anything else to it besides?
Yeah, because if you look at it, it's also floated to the right. It also has the same width. Agreed?
Okay.
So you could put a comma in that case and actually put, yeah, you could do that if you want. But for right now, I'm just going to copy and paste this just to make life a little bit easier. There we go. Save that. Refresh the browser. Things should be looking quite special. Text wrap should be gone. Should be feeling pretty good right about now. We're almost there. And now the last step is we need to get our main class name, which is just the main paragraphs, and the meta section, and we need to float those opposite of one another. So this is exactly the opposite thing that we did with the third level and the second level heading. Okay, third level heading floated to the left, second level heading floated to the right, and we made sure the widths were set so that the gutter, the 20 pixel gutter, remained. Everybody with me? In this particular regard, we want to do the opposite. We want the main content to float to the left, the meta to float to the right. Once again, though, we want to make sure that the widths are set so that we make sure that the gutter remains. But there's going to be a little bit of a monkey wrench thrown in here because our context has shifted. So let's go back over here. Here are the things we're going to be dealing with. We're going to deal with a class name for main and a class name for meta. Those are the two selectors we're going to be creating. Let's start with main first. So in your CSS, class name main. Which way is the main division going to be floated? Left or right?
Left.
Left. So float it to the left. Let's think width for a moment in terms of pixels, shall we? Let's think of pixels. Now, I already gave you this particular answer because we set this width to our first level heading. There's a hint. You remember, if we take a look here, the width of the main section needs to be derived from subtracting 124 pixels plus a 20 pixel column to its right and 124 pixel plus a 20 pixel gutter on its left. So 144 plus 144, I can do that math in my head, that's 288. So take 288 from 988, and you get
700.
700, which happens to also be the same width as what other element? Our first level heading. Remember that? That worked out fairly nice and neat. For right now, let's go ahead, if you want to, we can go ahead and see this first level heading, and you may be tempted to just go ahead and copy and paste this, but don't. Don't. Because guess what? It'll be wrong. Let me explain why. Look at the context for the first level heading. The first level heading's context is the overall design. Agreed? If we come down here to main, the main is not inside of an element that is 988 pixels wide. It's in an element that's this wide. Take a look. See the width for the content? See the content division? What is the width of the content division? It's 844. So the percentage that we need to create is it needs to be 700 pixels, but it needs to be presented as a percentage of its overall parent element, which in this case is 844. The percentage is 700% of 844, not 700 pixels of 988 pixels. That's the wrong context. Do you see how our context shifted? Its parent element has a completely different width now. So now we have to use its parent element's width for the context. Yes?
Does it matter the order in which you have these listed? 'Cause I know it has, some of them have the,
Not really. Not in this case. It doesn't really matter the order. So the target, the math is going to be 700 pixels divided by our context, which is now shifted. It's 844 pixels. If we do the math there, that should be 0.82938. Everybody see that? Does anybody not understand why the context shifted? Well, we're not dividing this by 988, but instead dividing it by 844. Is anybody getting tired of all these numbers? Okay. We're almost done. We're almost there. So we need to change this to expressed as a percentage, 82.938%. Now, if you had simply copied the second level heading, look at how different the percentages are. The second level heading is 85, or excuse me, the first level heading, pardon me. The first level heading is 70%, give or take, of the overall design. The main element, even though it's the same number of pixels that we're trying to represent, is 82% of its parent container. So if you just simply copy and paste, you would have gotten it completely and totally wrong. This particular element would have been much, much smaller had you set it to 70%. Anybody have a question about this? All right, we save this and refresh the browser. There we go. Looking better? Yes, it is. Next thing we got to do. If we notice, the meta isn't quite right. It's essentially text wrapping the floated element. Well, we don't want to do that. We still need to float that, and we need to set its width, because its width right now, it's floating inside of a space of 144 pixels, the equivalent of. It doesn't need to be 144, it needs to be 124. So let's go back in here, and let's go ahead and target the meta element. So we'll create a class for meta. Which direction does this need to float? To the right. If you set its width to 124 pixels, save it and refresh the browser, it should look correct now. You should pretty much have exactly what our image says it should be. But now we also need to convert this to percentages so that it's fluid. So let's do the math again. What's the target? 124. What is the context? 844. There we go. Equals, yeah, 0.14692. Or expressed as a percentage, 14.692%.
Is the 844 is based off the main?
The 844 is based off the content, which includes both the main division and the meta division. And now, if you expand the browser window, max width will stop the design exactly at the equivalent of 988 pixels. And if you start to collapse it, everything will start to collapse proportionally because you're using percentages. Isn't that nice? Yes.
This makes things a lot complicated.
Yes, it does make it more complicated.
The way this is designed, was it designed like section by section? Is that the new way you're supposed to start designing now?
What do you mean?
Like you created, like usually we just use a one big container for the whole event.
And this one did too. The division with an ID of page was its one container for the design. But if you think about it, if you think about it in sections, so how this was structured was in sections. Yeah, or compartments if you want to think of it that way. Yeah, it's a bit more complex, but then again, you know, a lot of the designs we've been doing in this class have been fairly simple by contrast. Yes? Yes. Does anybody have a question about the math? Anybody have a comment about the math? Okay. Well, yeah, other than it sucks. Yes. Okay. Now, this opens up a whole new way of looking at web design, does it not?
Yes.
I agree. At first, when you look at it, you kind of feel like you want to go over to the wall and bang your head a couple of times. And want to know why in the world would anyone want to come up with something like this. But once again, you got to remember that everybody in web design was going along and having a grand old time up until Steve Jobs introduced the iPhone. And then he followed that up 2 years later with the iPad. Up until that point, everybody was essentially using grid-based design for all of their work. So what we found out is that, okay, great, grid-based design, we'll base it off of whatever the monitor, the most common monitor resolution that we had. And we found out that a lot of people would design things with 960 pixels in mind. Because 960 pixels, if you're talking about grid-based design, can be divided up into nice chunks. I mean, you can divide 960 by a plethora of numbers. You can create really small grids, really large grids, and everything in between. 960 is a very utilized divisible number in math. So it made sense to base everything on that. Also because up until about 2007, 2008, everybody was running around with monitors that were probably anywhere between 1200 to 1400 pixels in width. So 960 struck a really nice chord. However, the minute the iPhone and the iPad came out, everything changed. Because now what ended up happening was web designs that were set at 960, which to some people may be, depending on their screen size, a little bit on the small end, they were much larger than the devices that they were being rendered on. So we now had to find a way to be able to shift our designs so that we could create a outer limit, a maximum width, so that measure links didn't get too long, but at the same time allow it to very comfortably kind of become fluid and fit within smaller devices. Now eventually we found out that this particular technique worked out only so well, because obviously if I've got a 3-column layout on an iPhone, the left and the right column, that's not exactly ideal. Agree? Now, of course, if I'm using this on an iPad and I've got a bit more space, that's not so bad. But on an iPhone, not so good. So the next evolution in the fluid grid design theory is to take it one step further. And that is, yes, we need to create a fluid grid to begin with, because we want the design to play nicely with smaller devices, but also have a cap, so to speak, on larger devices. So our design itself doesn't become too ungangly, doesn't have such large line lengths that it becomes unreadable. So the next step after that is, how do we tame smaller devices? How do we adjust the layout of our actual design to better flow on smaller screens? So what we're going to learn later on is we're going to repurpose that media attribute. If you remember back in our HTML, when we added our CSS, we included a declaration of media. The media attribute basically said, this CSS should be loaded up if this particular page is being viewed on this particular media. So screen and projection fit any device with a screen. That means whether it is a mobile device or whether it is a desktop device, a laptop, netbook, the projector that I've got here in the classroom, it doesn't matter. This CSS will be loaded up on those particular devices. Everyone with me? Later on, we'll talk about the concept of responsive design, which essentially utilizes this media for our own purposes, where we can actually go further and say we can target devices based on their overall width. So we could say, hey, if this device only goes up to this particular width, then we know it's an iPhone. Or if it only goes up to this width, then we know it's a tablet. And based on those assumptions in our CSS, we can reutilize or reshift the layout to better fit those devices. So in some cases, for instance, in this particular layout, we can remove certain floats. So instead of having multiple columns, we can have 2 columns, or eventually go back to 1 column if we wanted to. So that is essentially the direction, the evolution that we're moving towards. Now we'll do some more things here with fluid grids, but I want to close out today talking about something I promised you guys on Monday, and that is a different media type. In this case, I want to show you how you can target your website, more specifically your CSS, for print. You guys remember this? All right, now, if we save this, go back into Safari and go up to File and press Print. If you'll notice, the print preview I have here doesn't look anything like our design, does it? The layout is completely different. Now the reason for that is the printer is neither a screen media type nor a projector media type. Therefore, our CSS doesn't even load up.
Isn't that how it was set originally before we started putting the CSS in?
Yeah, in fact, it's basically printing an unstyled version of this page. In fact, the font itself is actually set to Times. See how that could be a problem? So, here's what we're going to do. We're going to create a separate print style sheet. We're going to load it up. And when we go to print it, we're going to make sure that only the content we want prints. And not only that, we want to make sure that the size of the fonts are set correctly as well as the typeface. So, here's what we're going to do. Go back to Adobe Edge Code, please. And actually, first off, I'm going to print this off just so that we can see what this looks like. There we go. Go back to Adobe Edge Code and let's create a brand new CSS document. I think I just printed it to the wrong room. Will somebody else please print their Safari page out? Just one. Well, I don't care. If 3 of you guys do it, I don't care. Just someone print out your Safari page, please. Then create a brand new document in Adobe Edge Code and save it to the same location as your Fluid Grid HTML. So if it's in your flash drive, make sure you save it to the right location. This time though, name it print.css. Thank you. When we're done with this, I'll print off another copy, or we'll print off another copy, and you guys get to see the difference between the two. So save it as print.css, please. Now go back to your HTML and let's link to this particular CSS document. So right after our link to our screen.css, let's create a new link. Set its href to print.css. Once again, it is a style sheet, so make sure your relationship is set up properly. And for media, set it to print. Now, here's the wonderful thing about this. Any CSS that we add to the print.css document will not apply when you're viewing this web page in a browser. Won't apply when you're viewing it on a mobile device. It will only apply when you go to print it. Now, on the other hand, as we just saw, when we go to print it, our screen.css document is completely ignored. Everyone got that? So this means the print.css document can contain all of the CSS properties and selectors that we need to help us properly style our document for a printer. Now, there are a lot of really neat properties that you can utilize in a print style sheet that are only applicable to a printer. I made mention of some of these things on Monday. We'll learn a lot of these things following spring break. But some of these things you can do, you can create page breaks, which is very similar like in InDesign where you can choose a page break for a specific paragraph style when you go to export out to an EPUB, which is nice. You can also utilize the same units of measurement that we're all familiar with when we use print. So for instance, welcome to points. You can even use picas if you wanted to. Okay, probably better off using points. Okay? Now, of course, line height is still line height. You can't just use leading. So that's a small little consolation. But the other thing that you need to be aware of is also when you go to print, certain printers do not like certain fonts, especially if they're not installed on the computer. So you want to make sure that whenever you are utilizing a print style sheet, you always set your alternative options for your font family. Okay, so you make sure you have different fallbacks set up. So as you may know, certain Windows machines do not have Helvetica on them. Certain printers don't like printing in Helvetica. So you want to make sure if you're going to use Helvetica, you have an Arial as a fallback. Okay? So same thing goes as you're doing display. So let's go ahead and first things first, let's take a look at our actual document. So go back into Safari and let's see if there's any content in here that we really do not need to include on a printed version of our article. Yeah, do we really need the line a blog entry?
No.
No. Anything else?
Maybe good tags.
Yeah, what about the tags? Do we really need to know what the tags are? No, we don't. So let's go back into our HTML and let's take a look. Now, the info, the third level heading is tagged with a class name of info, so that's pretty easy. In our print style sheet, we can target that specific element and we can basically tell it to not display that element when it goes to print. Show you how that's done in a minute. If we come down here to the meta though, is there any way that we can target our tags?
No, it's not taking out the date as well. Pseudo is the one.
There we go.
Last
There's thinking outside the box. Yeah, remember first child?
last child.
Remember that? Is that paragraph a first child or last child? Ah, so there is a way we can target it without actually altering our HTML, isn't there? It's not bad. Okay, so let's go ahead and do this, shall we? Go back into your print CSS. And the first thing we want to do is let's go ahead and target the body element. And let's change the font family. In this case, instead of printing in Times New Roman, let's go ahead and print it in Georgia. Set the fallback to Times, and then finally serif. Next, if we take a look at our document itself, you'll notice the first level heading and the second level heading are sans serif fonts. Agreed? All right, so here's what I want you to do. Create a group selector, first level heading, comma, second level heading, change its font family to a sans serif font with a proper fallback.
Can you repeat that?
Yes, target the first level heading and the second level heading, change its font family to a sans serif with a proper fallback. Okay, now we could go one step further if we wanted to and start adjusting things like font size and change font size to points and do all wonderful things like that. But we're not going to in this regard. What we're going to do right now is we're just keep it simple. We're going to go ahead and remove the blog entry and that paragraph that has our tags. So to do this, anytime you target an element, you can remove it visually from the actual design by setting the display property and set the value to none. So once again, we're going to create a group selector. So we're going to start off by targeting the info class name. I'm going to create a new line because the next one's going to be a little bit long. So the info is actually our third level heading, right? Next, what we want to do is we want to target this paragraph within the class name meta. Now, if you remember, when we targeted the very first paragraph in our content, in our main content, we said .main, and then we put a space, P for the paragraph's type selector, colon, first dash child. Remember that? Here's what we're going to do for this one. You want to target first the meta class name, so .meta, space, paragraph type, colon last dash child. So make sure you have a comma between the info class name and this one. So we're going to use a descendant selector. First, we're going to target the meta class name. Inside of that, we want to target the paragraphs, specifically the last child, the last paragraph of our element, and set its display to none. When that's done, go back, refresh your browser. Everything should look exactly the way it did a minute ago. But when you go to print it, things will be different. So somebody please save it, refresh the browser, and please print me off a copy.
No, the title is still Sarah. Which one is Sarah?
Should be. Mine wasn't.
My blog entry and tag are still there.
Well, not until current.
Oh, yeah. And when I go, I think I got that. Save.
You forgot to put your commas between George and Tubbs. So that's the area on Sunset.
Wait, why is my...
No. Oh.
You also have to make sure it's loading the actual CSS. Safari.
Jesus.
Jesus, man.
So after that, reference the CSS, stores on relationship reception, just grab it in. And just do the same thing, like, make sure that this needs script.css and all that.
Oh, you're not seeing that?
No, I just was gonna tell him that.
Okay. Refresh.
I guess I'm good.
There we go. Okay.
All right.
I didn't say my HTML. And there we go.
And whoever printed this got it right. Oh, it's not loaded. All right.
The last child.
Last child is included. We didn't put space.
There's one right across the screen. Oh, no. I'm trying to like the big bold.
Is it working?
I'm really hoping it'll go to recording because I didn't do, for Spanish, we have like this thing, like a presentation, and I didn't do it.
Unless you
It's like we're in test grade too, I just haven't done it right.
This is
You know, what's like, they're gonna print something.
this place across the street. Japanese people make
You see it, you heard it,
And then it'll show up.
you put it in the wrong place.
I have no idea. I don't do
Yeah,
sushi.
that's correct. You're supporting.
I don't do sushi. So
No. I don't know why it's not moving here.
fish doesn't work for me.
It's fine. All right, so I'm going to leave these up here at the light table, and you guys can actually see the difference between the two.
Sweet.
But yeah, so then it should have worked. You should have seen a change, immediate change, when you go to print. Now, certain content is not going to be included on the actual printed copy. Now, the best example of a really nice print style sheet is actually at a list apart. So they went and changed all their articles today. There we go. So if you look, we've got all this menu up here. We've got ads. We've got all these things that are actually a part of this particular article. And if we scroll all the way down past all the squids, there's comments. Right here, 29 reader comments. There's additional columns that you may want to look for. Does any of that stuff really? Do you really want to print all that stuff? Probably not. So if we take a look at what happens when you go to print a list apart, if you look, get a list apart, really, let me save this as a PDF, that way we can actually see what this looks like. Here we go. So here it is. Here's what the printed page is actually going to look like. So you've got the title, you've got the byline, there's the name of the site, obviously, you got this wonderful graphic. Here's the actual text. It's in one column now. Notice the ad is gone. Some of the side content is gone. Page breaks are done really nicely. Code is properly colored and looks great. These are all, and then you've got the bio for the author, and then at the very end you've got this little icon and then an ISSN number, but no comments, no additional articles, no menu, no superfluous crap that you really don't want when you go to print because you don't want to waste all that ink and all that paper. These are the sort of kind of detail-oriented touches that when you add to a client's website, it adds value. Because users, and how many people here have actually printed web pages before?
I copy them.
Or at least saved them.
Or yeah. Well, you copy and paste probably because you got tired of going to print and you print a bunch of stuff that you don't need. Right? So, for instance, for a while, when you went to actually print the TCC website, it would print the entire menu on the first page. So all those drop-down menus that we had on the TCC website would just be giant links all the way. I mean, the entire first page was just nothing but links. It was ridiculous. So print style sheets are one of these things that when a user finds a website that if they go to print something for and it plays nicely, that just goes to add to the overall experience of the user for that particular website. Okay, so for instance, if we were to apply this logic to your blog, the blog that you're currently writing, that you've been adding to all semester long, what are some of the things that you may not want to include when you go to print it out?
Background image.
The navigation bar.
Background information, the navigation, right? I mean, who cares if the navigation says week 1, week 2, week 3? Does that mean anything when you go to print it out? No, it doesn't. So you could easily create a print style sheet to exclude your navigation. And if you place your navigation in an element like, say, the nav element, then all you had to do in your print style sheet is use the type selector nav and set its display to none. It would print. Now, there are a lot of other things that you can do when you go to actually create a print style sheet. Print style sheets can become very complex. Obviously, the one that we've created is very simple and very basic. But there are some really neat things that you can do when you're starting to get into pseudo classes and pseudo selectors, in which you can do things. For instance, you can tell in a print style sheet, you can tell the printer that whenever it comes across an anchor tag. Now, an anchor tag, when you go to print it out, does it do anything?
No.
No. So it's pretty useless, right? There are certain techniques when in the print style sheet you can actually find, using CSS, you can locate what the actual href value is. So what the actual link is. And you can tell it to print it out in brackets next to the anchor tag. Now you can't click on it, but you can at least see what the actual URL is for that anchor tag. That's pretty nice, right? So there are a lot of really neat tips and techniques that you can get around with when you go to print. Now the great thing about it is every single one of you in here have been exposed to a lot of different design ideas and theories and concepts and skills when it comes to print. So when we actually start creating style sheets for the printer, a lot of the stuff is actually going to be very similar. The best way I can actually put it is think about creating your print style sheet as you would your paragraph and character styles in InDesign. You understand how that works out? They're kind of a one-to-one. In fact, as some of you who have taken my Digital Publishing 2 class know, that when you actually go to export out to EPUB, your paragraph styles essentially become CSS. So it's kind of an interesting way kind of going back and forth. So print style sheets, screen style sheets, basically it's all just a matter of that media attribute. So if you remember back in Web 1 I said name it screen.css and everyone was like, why do you call it screen.css? The name doesn't matter. I just named them that way because I know in my head that's the CSS file that specifically is going to be used for the screen media type. Print.css is specifically going to be used for the print media type. If I had a CSS document just for handheld devices, I would call that handheld.css. The name doesn't do anything magical. It doesn't automatically trigger a media. You have to actually specify media using that media attribute. Does anybody have any questions? Any questions about M's or percentages? You guys just want to get out of here. That's what it is. You're all looking around at each other like, dare ask a question. Okay. Well, thank you guys very much.